Okay, thank you very much for this question. I suppose it's always difficult to talk about myself, but I will try. My current research is mainly focused on a couple of topics that could fall under the umbrella of intelligent systems, or what you call today artificial intelligence. So I'm interested in machine learning that is of a particular relevance when it comes to ideas of processing data and knowledge. So I would call it knowledge-oriented machine learning. So this is the topic that surfaced just recently, and in my opinion it offers an interesting sort of insight into the ideas of some challenges that we witness today in machine learning. I'll probably talk about this more later on. Another topic or another area concerns granular computing, the area that has a relatively long history, and the area that tries to look at an interesting aspect of building some information granulars, processing granulars, and communicating those granulars in the environment of intelligent systems. In the past, I was doing research in fuzzy sets. I'm still sort of quite active in this area. However, I prefer using the term granular computing and information granulars as being more, I think, reflective of today's development in the area. In addition to that, I'm looking at some aspects of neural networks, and again from the perspective of granular computing. So in this sense, some of the topics that are very much visible today, they could be expanded, they could be researched, they could be investigated in a broader and I think more, I would say, successful and more promising domain. Okay, I think this is really a very timely sort of question, because it is needless to say that what we see today in artificial intelligence is nothing but machine learning in disguise. In other words, we benefit from huge amounts of data that are processed in a meaningful, constructive way to give rise to some models that allow you to do classification, allow you to carry out some association analysis, allow you to carry out some prediction task. But we have to admit that having these huge masses of data is a genuine advantage and benefit, but also it is a certain curse, in the sense that we are not seeing too much beyond the data. So the question is, what if your data are incomplete? What if your data are manipulated? And can you avoid this situation, or can you eventually identify this situation and eventually combat some possible problems? And this is not so obvious. I think the key tendency today is to think about different schemes of data fusion, with anticipation that if you have some mechanism that you fuse data or you fuse models that are quite different, then you can eventually battle this problem. But we have to admit that there is an aspect of knowledge that is always present in any problem being solved by human beings. Well, that's really, in many cases, we are really superb than machine, and it will happen and it will continue to be this way in the years to come. However, knowledge is far more difficult to quantify, it's far more difficult to formalize. There have been some interesting developments in the area of artificial intelligence under the name of knowledge representation. A few decades ago, they became popular, but then they started to somewhat disappear or started to become less, I think, in vogue. But it was obvious because it was too difficult. So now it's probably a good time to come back and think about what I've mentioned earlier as a discipline of knowledge-oriented machine learning. So this is one of the possible challenge. Obviously, this challenge is quite tied to the questions that we are seeing today as being still unresolved by machine learning, and it's unresolved, it's really implied by machine learning. So what we have in mind is just the question of explainability, interpretability, transparency, the question of computational sustainability, the question of credibility of machine learning constructs. So hopefully some of these items will be successfully addressed in the future. Well, you know, that's a difficult question because nobody can predict the future. We can only sort of speculate. I would say, and that's I think somewhat related to what was mentioned earlier, that you have those challenges, or if you like, you have some opportunities. So first of all, we have to become very much aware of the fact that computational sustainability becomes really a question. I think if you go to the situation that is witnessed today in terms of computing requirements, we encounter scenarios that have not been seen before. So in other words, you are talking about design of models, for instance, large language models, that really are at the reach of big companies having enormous computing power and also having quite hefty budgets to carry out computing. If this is not available to each and every member of the academic community, this becomes a general structural challenge for the ongoing research. So it's a question, how are we going to address this? And obviously I can hear people talking about, you know, more advanced hardware. Yes, I agree with you on this, but it's not necessarily a solution to the problem. It has to be done in a sort of smarter way. Something has been done in the past, maybe not that much emphasized, and probably we'll get back to this. For instance, under the headline of transfer knowledge. So in other words, you can do something smarter by referring to the past. You gain some experience in the past, maybe you have to reuse this experience in a more sophisticated and well-informed way. Well, that's what we as humans are doing every day. Okay, it's again very subjective, but my answer is, or suggestion, is very simple. Just be yourself. Do not follow trends in a blind fashion. You can see that today development of different activities and achieving different goals in the area of AI, computational intelligence, machine learning, this entire trend or the pace of developments is very huge. Also, you can see a lot of buzzwords. try to understand what is behind the buzzwords. Try to understand what is the essence of this particular concept, how much relevance it has in solving some class of problems. So I say, be yourself in the sense that you have to think to do how you like some categories or some ways of dealing with problems. Are you more interested in fundamentals, or you are more on a different end of the scale that you would like to first to get some hands-on experience? Both of them these approaches are good, but some people are more interested in a particular direction. Some other people are sort of doers. They simply think they are excited if they can sort of write some code, they can experiment, they can essentially analyze the results, they can get better understanding. And another strong advice is, remember, machine learning and AI tools are not play and plug devices. So you do not plug this and you play and you get the result. This is the most kind of, I would say, misleading perception that is very much some imprinted on some human minds. So any undergraduate student can do research that is really at the kind of essentially at the boundaries of the frontiers of a very I would say rapid progress. Well, there are some interesting things, but I think as if you are considered to be a researcher, you have to be a little bit more perhaps well sort of defined in terms of your goals. Yes, I think that's an interesting question, because it's always the issue that comes where you have a new, ambitious, and a well-established journal, because I have to admit that the journal has a very short history, but has a lot of accomplishments and has really a number of successes. And I think it's poised to be highly successful in the long run because of the composition of the body, of the editorial board, and the leadership of the editor-in-chief. What are my advice and what my suggestions? I think it's important that the only papers that are published are of high quality, and the papers that contain a substantial amount of original material. Obviously, somebody would say, well, originality is a very subjective feature. Yes, to a significant extent, it's a good point. But I think the papers that should be considered should be original, but also they should be well written, well organized. Especially in the era of complex engineering constructs that are very difficult to describe in a very well organized manner, it becomes of paramount importance that the reader can really follow the kind of main line of thought and can become convinced that essentially this proposed solution is just coming with a clear logical connotation. So I do believe it's really a very much open area, because you may have different ways how you can achieve the goal of excellence of the journal, but maybe these two factors could be quite useful here. Thank you.